Okay, so I put together this video because I want you guys to be able to see how everything we've talked about in the last few lessons all come together. We've talked about equations in the form y equals k times x. We've talked about graphs in the form y equals k times x squared. And more recently, we talked about graphs in the form of y equals k divided by x and k divided by x squared. Now, you may not be able to recognize right away how there could be some similarities here between these different graphs, but I think if we take a second to look at some of these, I think you're going to be able to see how this all starts to come together. And maybe it'll help you even keep some of these different graphs straight so you can do better on the quiz and do better on the test. So let's first look at these two graphs that I have on the screen. Y equals k divided by x and y equals k times x. Now k, you might look at that and think, well, one's a curved line and one's a straight line. So that's obvious, that's an obvious difference. But let's look at this a little deeper. Take a second to look at what quadrants our graphs are in. If you notice, the graphs are in, both of these are both in quadrants 1 and 3. May not seem like much, but here's an easy way to remember it. If you think about dividing, like let's say if I had a class and I was going to divide the class into two groups, I'd be breaking you apart. That's what we're doing here with division. I have k times x in that first graph. In the second graph, I have k divided by x. And what we're doing is we're taking that graph that's connected and we're breaking it apart into two pieces. And both those pieces still remain in the same quadrants. They're still in both quadrants 1 and 3, but they're not connected. They're broken apart. Let's look at some other relationships that exist here. Let's look at the domains. The domain for the first graph, y equals k times x. Think about what that is. That's going to be all real numbers. It goes infinitely in both directions. It includes every point going infinitely to the left and infinitely to the right. Well, what's the domain in the second graph? Well, you should remember that in that second graph, the domain is going to be all real numbers except 0 because we have that asymptote. The asymptote is that invisible line where as you look at the graph, yeah, it goes infinitely in the positive direction and infinitely in the negative direction, but as those graphs get closer and closer to 0, they bend, meaning that they're not going to be exactly where x equals 0. So it'd be all real numbers except 0 is your domain. So think about the range. The range in that first graph, well, it goes infinitely up and it goes infinitely down. So the range there is also going to be all real numbers. What's the range in the second graph? It's all real numbers except 0. So you might see some similarities here where the first one, it's all the numbers. Any number you can think of. In the second graph, it's any number you can think of except 0. And like I already said, the quadrants for both of these are in quadrants 1 and 3. Let's look at some other graphs. Let's look at these two. Remember, again, the first graph, that's in quadrants 1 and 2. The second graph is also in quadrants 1 and 2. And if you look to see what's going on there in that first graph, we have y equals k times x squared. It's connected. Y equals k divided by x squared, I'm dividing it, so I'm breaking it apart. So it's still in quadrants 1 and 2, except for they're not connected anymore. So let's look at the domain now of these two graphs. The domain for that first one is all real numbers. But the domain in the second one is all real numbers except 0. Let's look at the range. The range in that first one, y equals k times x squared, the range can be anything. It can be anything, I should say, greater than or equal to 0. Because it starts at 0 and it goes infinitely up. The other one is similar, except for the range is just where y is greater than 0. If you said y was greater than or equal to 0, you'd be wrong, because it doesn't include 0. As you look at the graph, it goes down, but it doesn't ever touch the x-axis where y is equal to 0. Now let's look at these graphs some more. So we're saying that the domain is all real numbers for y equals k times x and k times x squared. But the domain for k divided by x and k divided by x squared is all real numbers except 0. Can you think of why that would be? Why would 0 be such a unique number in these two situations with k divided by x and k divided by x squared? Did you think of it? Well, k divided by x and k divided by x squared, your domain, remember, is referring to your set of x's, and both of them can't be 0. So why can't x be 0? If you haven't figured it out, it's because you can't divide by 0. If you don't believe me, try it on your calculator. Your calculator will give you all sorts of weird error messages because you can't divide by 0. So that's why with both those graphs, 0 is such an important number because it can't exist. It can't be a part of the domain in k divided by x or k divided by x squared. So hopefully this video has maybe helped put some things together for you, and hopefully you've found now that there is some relationships there, and maybe now you can keep these different graphs straight. So good luck as you continue through the chapter.